Thank you so much for joining this lesson. We shall be looking at Mathematics Paper 2, Section 2, the Moi Girls High School Mathematics Paper 2, September paper. This is a post-mock. Look at number 1. A quantity P varies directly as the square root of Q and inversely as the square of R. Determine the percentage change in P when Q is increased by 44% and R decreased by 28%. Remember, P varies as Q and also as R, meaning that when Q and R are changed, then P will also be changed proportionally. Therefore, let's first interpret the information that P is varying directly as the square root of Q. Then inversely, so we divide. When it is inverse, you divide square of R. So square of R means R squared. From this now we can have an equal sign introduced together with a constant of proportionality out of R squared. This is the original expression of P. Now, after the changes, we can also express the new expression for P. So we get a new Q. So by Q now becomes 144% of the original Q because it's going to increase by 44%. So it shall be 1.44 of the original Q. Then for R, new R shall be 72% of original R because R is decreasing by 28%. So this becomes 0.72 original R, like that. Now with the Q and R, we can also get the new P. So P shall be given by the square root of the new Q, 1.44 Q. Remember, there is a constant here, out of the square of the new R. So this is the new R, P square. So what are we getting from this? New P shall be a constant multiplied by 1.2. So we can start with the 1.2, because the square root of 1.44 is 1.2. A constant and the root of Q remains like that. Out of, when you square 0.72, you're supposed to get 0.5184 R squared. So we can divide 1.2 and 0.5184 to give us 2.3148. 2.3148 constant, the root of Q, out of R squared. This is now the new expression of P, meaning that we can get percentage change of P. We just need the change out of original times 100. So the change shall be 2 points, sorry. That's a 2.3148. Okay. The root of Q out of R squared minus the original. Then we divide by out of R squared, like that. For us to get percentage change now, we are supposed to multiply this by 100. Remember, K is appearing twice in the numerator, so we can factor it out to remain with 2.3148 minus 1 out of K, the root of Q, over R. So from the numerator and the denominator, they cancel out. You're supposed to multiply this by 100. So what we shall get here after subtracting 1 is going to be 131.5%. This is an increase. Increase because the change is positive. In case you work out and you get a negative change as a percentage, it means the quantity has decreased. But as long as the change is positive, then there is an increment in the quantity P. Solve the equation 2, the logarithm of x plus 2 base 4 minus the log of 3x minus 2 base 4 equals to 1. Because of the constant on the right hand side, we can just introduce logarithm to base 4 and say this 2 the log to base 4 x plus 2 minus the log to base 4 3x minus 2 equals to the log of 4 to base 4. Since the log of a number to the same base is usually 1. So if the log of a number to the same base is 1, introducing log 4 to base 4 doesn't change the expression or doesn't change the value of 1 like that. Then from there, we can talk about the law that says that n, the log of a, this can be solved by taking the logarithm of a raised to n. Therefore, here we are having the log to base 4 x plus 2. Now this one has to be raised to power 2. The 2 here becomes a power according to this law. The log to base 4 of 3x minus 2 equals to the log to base 4 of 4. Remember also that when we have the logarithm of a minus the log of b and the bases are the same, then you can simply take the log of a out of b. And with that now, the log of b, we should have x plus 2 squared out of 3x minus 2. This is equal to the log of 4 to base 4. At this point, we can now drop logarithms, then we equate the left-hand side to the right-hand side, giving us, okay, I have to expand x squared plus 4x plus 4, then over 3x minus 2 equals to 4. That's after dropping the logarithms like that. At this point, you will allow me now to solve this one by first I cross multiply to do away with the denominator and such that, let me utilize the force here, such that as we remain with x squared plus 4x plus 4, we shall have 12x minus 8. Yeah, so 4 multiplies everything on the denominator. So x squared minus 6x. Is it 6? I'm trying to group 4x minus 12 when 12 goes to the left. And that automatically becomes negative 8, not negative 8x. Then we are having 4 and 8. 8 becomes positive, making this one now 12 equals to 0. So now we're supposed to talk about two factors whose product is 12 and sum negative 8. And this is negative 4 and negative 4. Meaning that we can re-express, instead of negative 8, we have negative 4, then plus 12 equals to 0. In the first two, we can factor out x to remain with x minus 4. And we also factor out 4 to remain with x minus I'm looking for the factorization there. What do we remain with in the brackets? And are we doing the right factorization? Are we doing the right factorization? Just a minute there. We check what shall remain. No, I don't think we picked the right factors. Look at -2, -4, and -4. Their sum is -6, yes, but their product is not 12. So we would have gone for some different factors. Sorry. We had to examine that one in a better way. Sorry for that. Okay. What if we talk about -6 together with -2? Product shall be 12 positive and sum -8. Yeah. So now we can work with these ones. So look now, instead of -8, we're having -6 and -2. We factor x to remain with x minus 6. Then we factor -2 to remain with x and -6 equals to 0. So x minus 6 from the brackets, and outside the brackets we have x minus 2 equals to 0. So either x minus 6 is 0 or x minus 2 is 0. So the first option for x is 6, and the second option for x is +2. So those are the two possible values. Those are the two possible values of x from that equation. We can proceed to solve number 3, which is a binomial expressions and expansions. Remember, you can reach out for consultations and also for more programs and revision materials through 07 04 15 33 66. Teacher Boniface, that is my line. Feel free to reach out. Now, using binomial expansion to expand, or use binomial expansions to expand 1 plus 1 over x raised to power 5 up to the term in x power -3. So we are supposed first to write the binomial coefficients of power 5 up to the third term. Okay, the fourth term, because in the first term we will not have the powers of x, but by the time x will be assuming power -3, we shall be in the fourth term. So we need to start with 1, 5, 10, 10. The first 4 terms. So in the first term, 1 assumes power 5, and 1 over x assumes power 0. In the next, 1 goes down to power 4, as 1 over x takes power 1. Then 1 takes power 3, as 1 over x takes power 2. Then finally 1 takes power 3, now 2, as 1 over x takes power 3. So this is going to be 1 from the first term here. We're going to get 1 plus 5, and the other one remains the way it is. So 5 over x, then plus 10, and x is now over 2. then plus 10 again, and x power 3. Remember, we are still having the power of x, because when you take 1, then you add 5, x can take a power of -1, because it can raise to the negative, it can go to the numerator, then the power changes to a negative according to indices. Plus 10 x power -2 plus 10 x power -3. So we can have the expression like that so that you may understand. We are in the fourth term where the power of x is -3. Now use the expansion above to evaluate 1.5 power 5. We are first supposed to equate 1 plus 1 over x raised to power 5 equals to 1.5 power 5. So we can equate the bases. 1 plus 1 over x equals to 1.5. 1 over x equals to 0.5 after subtracting 1 from both sides. Then we can say 1 equals to 0.5x. So that to remain with x, we divide by 0.5. 1 divided by 0.5 becomes 2. So now if x equals to 2, now we substitute it in the equations there and we can have a 1 plus 5 over 2 plus 10 over 2 squared plus 10 over 2 power 3. And when you use your calculator keenly to compute this, you shall get 7 and 2.5. 7.25, or simply 7 and a quarter, like that. So that's how you apply binomial expansions in working out numerical cases. At number 4, a question on the subject of a formula. Make x the subject of the formula t equals to the square root of y into x minus y divided by x minus k. We can start by squaring both sides because we can see the root is obtained on the right-hand side. So when we square both sides, it shall be t squared, but now the root sign disappears from here. Like that. Actually, to save on the steps, I can even expand now at this early stage. Xy minus y squared out of x minus k. We are making x subject. I can see 2 terms with x. Let me cross multiply so that I have t squared by x minus t squared by k equals to xy minus xy minus y squared, like that. So we need the terms with x on the same side. So t squared x minus xy. Then we take t squared k minus y squared to the right, like that. We can factor out x so that we have t minus y equals to t squared k minus y squared. Then how do you remain with x? You can take t squared k minus y squared out of t minus y. So I'm dividing by t minus y so that I remain with x alone. Okay, there could be a factor that can simplify out, but the mark is usually awarded at the earliest stage possible. We have already made x the subject. We've already made x the subject, so you don't need further simplification. That's already worked out. In number 5, we are taught to calculate the shortest distance in nautical miles between points A, 35 in the north, 30 in the east, and B, 65 in the north, 150 in the west on the Earth's surface. Remember, this is distance in nautical miles. Remember, it is the shortest distance. Therefore, again, you should remember that this is 30 east, 150 west. The thing I've been emphasizing, we are now dealing with what you call complementary longitudes, whereby if you want to cover the shortest distance, then you shall move across the poles this way. I'm picking the circle. Allow me to sketch it. I'm picking the circle. You know, we want to pass through the North Pole. So if this is the equator, 0 degrees, then we have some 35 degrees to where point A is, and some 65 degrees to where B is. 65 degrees to where B is. Meaning that, you know, I've said from A to B, the shortest route is the one. If you are moving from A, you pass through the North Pole, then the route is the same. You just continue flowing through the same longitude. The longitude doesn't change if they are supplementary. If you're moving through 30 in the east and you pass through the pole, you automatically enter 150 in the west. Therefore, you flow smoothly, following a great circle. So we want to get now the arc length. The arc length, and this one, this angle can now be found when we take, for us to get data there, we need to take 180, we subtract both 35, 180 minus, sorry, 35 and 65. You see? So we get 80. The data there is 80. So distance in nautical miles is given by 60 times theta when the circle is a great one. 60 by 80 shall give us 4800 nautical miles. So that is the distance in nautical miles along the great circle, or rather the shortest distance. 6. The gradient function of a curve is given by dy dx equals to 3x squared minus 8x minus 3. If the curve passes through the point -1, 6, find its equation. One thing that we're supposed to know is that gradient function is the derivative of the curve's equation. So the curve's equation has already been differentiated. For us to get back to the curve equation, we are supposed to do the opposite of differentiation, which is integration. So we are doing antiderivative, or rather integration, to get back to the function y. So the function y shall be given by, when we integrate the first term here, the power of x increases to 3, and the new power divides everything. When you divide by 3, the 3 shall cancel. Then in the next term, minus, the power of x should increase to 2, and the 2 divides, the new power divides the constant to give us 4 at this point. Then we have minus 3, x is introduced at that point, plus the arbitrary constant of integration. And with the arbitrary constant of integration, we can now use the provided information so that we may find the exact value of the constant. If there is a coordinate where the curve passes, then it means when x is equal to 1, according to the coordinate here, when x equals to 1, the corresponding value of y is 6. And so when we substitute here, we shall get the constant c. So y equals to 6, x -1 power 3 minus 4, -1 squared minus 3 -1 plus c. Maybe work out that. -1 cubed minus 4 into -1 minus 3 into, okay, the -1 there should be squared. negative 1 power 3 minus 4 into negative 1 squared minus 3 into negative 1. Oh yeah, we're getting 6 equals to minus 2 plus c. You know, from here, the value of c can be declared 8, because when negative 2 goes to the left, it shall be added. So 8 is very correct. With that, now we can write, this was a general equation. Now we can make it specific because we know the constant. Plus 8. A very good question. Very good indeed. 7. Now, given that vector OA equals to A, vector OB equals to B, and that P divides AB in the ratio 3 is to negative 1, express OP in terms of vectors A and B. Let me first of all just sketch this information. These are collinear points. We have point A here, whereby the position is given as A. Assume we have our origin there. This is point A. Then point B is the point here. And I have point B here, whereby this is vector B start. Then there is a P, which is an external divider, P here. Now, P divides vector AB in the ratio 3 is to 1, meaning that from point A to where P is, we have 3 proportions. Then to get back to B, we're moving 3 proportions, then 1 proportion backwards. So when you move 3 and 1 backwards because of the negative division, it means we have 1 proportion here and there remains 2 proportions at that point, simply because from A to P we add 3 and we are getting back 1 more division. Therefore, you see, B now can be treated as an internal divider of AP in the ratio 2 is to 1. That way. So that's how we analyze an external division, or rather ratio theorem, when the ratio has a negative. So we can say generally the position of B, which is vector B, equals to, when we take the ratio 2, we divide by total proportions, we multiply by vector P, then we add the ratio of 1, we divide by total proportions, and we multiply by vector A. That way. So we can say that 2/3 vector P, 2/3 vector P equals to B minus 1/3 vector A. How can we remain with vector P? The position of P shall be, we multiply throughout by 3/2. So by 3/2, it becomes 1.5 B. By 3/2, it becomes half vector A. Therefore, vector P in terms of A and B can be expressed as 1.5 vector B minus half vector A. Look at number 8. We are told that in number 8, 2 parallel chords, A equals to 4 centimeters, CD 10 centimeters, lie on the same side of the center of a circle, which is center O. The perpendicular distance between the 2 chords is 2 centimeters. They lie on the same side. Calculate the radius of the circle, giving your answer to 2 decimal places. I will start by sketching this information about the the chords. There is a certain center there. Then we have two chords. Of course, these chords are parallel to one another according to the information. So the one closer to the center is longer than the other one. The perpendicular distance between the two is 2. So we have 2 centimeters at that point. And we should also know that if this was 10 centimeters, that is CD, 10 centimeters, then this is 5. And this can be X. Then we can let this one be radius. Our radius shall be here. So we can express radius twice, because also this is also radius. Then we can say this, this is AB, meaning that if the chord was 4, then this is 2. So we can use the chord A, the chord AB, to say that in case we take 2 squared and we add the perpendicular height now, which is 2 plus x squared, we should get r squared, Pythagoras theorem. So we can expand this. 4 plus 4 plus 4x plus x squared equals to r squared, like that. That is a quadratic expansion. When we are squaring, the square of 2 is 4, then 2 times 2 and x, then x squared. We can group some terms here and have 8 plus 4x plus x squared being equal to r squared. What about using the chord CD? We will say 5 squared plus the perpendicular distance there, which is x squared, equals to radius squared, like that. We have one expression here and another one here. This one. And they are both giving us r squared, meaning that we can equate the two. If r squared equals to that and also r squared equals to this, then why don't we agree that 8 plus 4x plus x squared equals to 5 squared, which is 25, plus x squared. And from this, we can group terms. That cancels. 4x equals to 25 minus 8, giving us 17. And the value of x can be determined as 4.25 centimeters. So with the value of x, it will be very easy for us to find r, because we can use the known value of x and 5 to find r. So we are saying r squared equals to x squared, which is 4.25 squared plus 5 squared. So that now we take square root to find r. The square root of 4.25 squared plus 5 squared. This is a 43.0625 r. And remember, it's now to 2 decimal places. Shall be 6.56. According to the instructions, 2 dp accuracy. That's all. Yeah, 2 decimal places accuracy. That's a very interesting question. Very interesting. Look at number 9. And I hope you remember our consultation line 07, 04, 15, 33, 66, like that. That's number 9. Solve the equation 8 sine squared x plus 2. The sine of x equals to 3. X ranging between 0 and 360 degrees. You can see the trigonometric ratio which has been involved here is only sine, but that it has been squared at some point. Therefore, we shall not apply the trigonometric identity, but we shall let the sine of x be a certain unknown, maybe t. So that we say 8t squared plus 2t. Then the 3 which is in the right-hand side can be subtracted here to give us 0. We need two terms whose product is 8 by negative 3 and sum is 2. Two terms, when multiplied, they give us negative 24. When added, they give us positive 2. What about 6 and negative 4? Added positive 2, multiplied negative 24, yeah. So 8t squared plus, instead of 2t, now we can have 6t minus 4t minus 3 equals to 0. From the first 2, we are factoring out 2t, so that will remain with 4t plus 3 minus 1, 4t plus 3 equals to 0. Within the brackets, we have 4t plus 3. Outside the brackets, we have 2t and negative 1 equals to 0. So from the first term, 4t plus 3 can be 0, implying that t equals to negative 3/4, or 2t minus 1 equals to 0, implying that t can be half. So we have two values of t, and we shall get possible angles using them. Let's start with the positive one. We are saying that the sine of x had been let to be t, and now we discover it's half. Meaning that we need first to get a particular acute angle, let's say theta, whereby, yeah, actually I'm not even supposed to say we can get an angle theta by taking the sine inverse of half, shift sine half, which is 30. Then now we say x shall be an angle of 30 degrees, but in the quadrants where signs are positive. In quadrants where signs are positive. Therefore, we can have a, let me sketch what we call the unit circle here. Yeah, the unit circle. So this is the unit circle. We can give the 4 quadrants. Those are 4 quadrants. Then in the first quadrant, all the signs are, all the trigonometric ratios actually are positive. We measure them as theta. In the second, it's only sine that is positive, and we get the angle by taking 180 minus theta. In the third, it's only tangents that are positive, and we get the angle 180 plus theta. And finally, cosines are the only trigonometric ratio that is positive in the fourth quadrant, and we get the angle by 360 minus theta. That one. So with this analysis now, we will say the first value of x shall be 30, and the next one shall be an angle of 30 in the quadrant where signs are positive. And that is an angle of 30 in the second quadrant. In the second quadrant, we need 180 minus 30, which is 150 degrees. Then we go to the second, the second value of t, whereby we would say the sine of, can say an angle like alpha is 3/4. Allow me omit the sine first, so that I will conclude that the value of angle alpha equals to the sine inverse of 3/4. And this is 48.49. 59, that is degrees. So now the values of x again shall be an angle of 48.59, but in the quadrants where signs are negative. Where are signs negative? In the third and in the fourth quadrant. So in the third quadrant, we take 180 plus beta. That will be 228.59. 228.49. Then in the fourth quadrant, we need 360 minus 48.59, giving us 311.41. So all the angles now can be assembled. The values of x shall be 30, 150, 228.49 degrees, 311.41 degrees. So these are the four angles which satisfy the equation above. Look at number 10. A teacher's college can accommodate a maximum of 730 students. The number of male students must be at least 450, while the number of female students must exceed 277. Taking x to represent the number of male students and y to represent the number of female students, write down all the possible inequalities representing the information above. From the first statement, a teacher's college can accommodate a maximum of 730. So when we take the male, we add the female, the maximum we can get is 730. Therefore, less than or equal to. This college cannot accommodate beyond that. So the number accommodated can either be 70 or 330 or below that. That is the first inequality. Now, the number of male students must be at least 450. So these ones, at least 450 means the least they can be is 450 or beyond. So they are either 450 or above that. Must be at least 450. So when you talk about at least, it means it's either 450 or beyond 450, like that. Then finally, the number of females must exceed 277. So y greater than 277. Not or equal to, it must exceed. So the number of females is above 277, strictly above, not or equal to. Those are the three inequalities from the information provided above. It's number 11, yeah. Number 11, we told that the cash price of a television is 45,000 Kenya shillings. A customer decides to purchase it on hire purchase by paying a deposit of 15,000 Kenya shillings. Calculate the monthly rate of compound interest charged on remaining balance if the customer is required to repay the television in 8 equal monthly installments of 4,000 Kenya shillings each. In a deal like this one, we usually say that a compound interest is usually charged on the balance after the deposit has been made. So when deposit was made, there is a balance that remained. That is what shall earn interest. So we can look at the balance, which is our principal, because it is what shall earn interest. 45,000 and 15,000. This shall give us 30,000, right? And this is our principal now, because this is the amount to earn interest. Then how much will they pay at the end of the season? The amount now, instead of the balance of 30,000, this particular customer will end up paying 4,000 multiplied by the 8 months, 300. Okay, 32,000 Kenya shillings. So we know the compound interest formula that says that the amount is given by principal into 1 plus rate over 100 raised to n. So 32,000 equals to 30,000 into 1 plus a known rate. This one now should be raised to 8 interest periods. Now, we first divide through 32 by 30 to give us 1.067. This is equal to 1 plus r over 100 raised to 8. This after dividing by 30,000 all through. After that, because the right hand side is raised to power 8, we can obtain the 8th root of both sides. So 8 shift power for this value, it's giving us 1.0080. 80, then triple nines, okay. Yeah, 999. So this now equal to 1 plus 8 over 100, because the power 8 has been dealt with. Yes, the power 8 has been dealt with. So we can subtract 1 and have 0.008099 being equal to r over 100. 0.80999 equals to the rate. You know, this is the monthly rate now. This one is the monthly rate, and it becomes our final answer. Do we have instructions like 1 decimal place or anything? No, we are just finding the rate. So we can leave it at that. We can leave it at that point. Look at number 12. Now the equation x squared minus 6x plus y squared plus 14y plus 22 equals to 0 represents a circle. Determine the equation of its image and a reflection in the line x equals to 0. Its image. This line is also called y-axis. So that's why we are performing. That's why we are performing the reflection. First, let's get the center and also the radius of this particular circle. By first completing the square on the x, the terms of x squared minus 6x, we can add a constant here. That we also complete the square for y by also adding a constant equals to 22 becomes negative on the right. 22 becomes negative, right? Then we add the two constants also. So the constants you add on the left-hand side to complete the square for both x and y, you also add them on the constant side. How do we get a constant to make the left-hand side a perfect square? The constant is usually given by the value of b over 2 squared. So negative 6 over 2, then we square. That gives us a 9. 14 over 2, then we square. That gives us a 49, right? So we'll be having 9 and also 49. Negative 22 plus 9 plus 49. That will give you 36 here. 36 like that. Then now on the left, we shall have factorization now. We factor the perfect square here. Square root of this part is x. The sign that follows is a minus. Square root of the constant is 3. Plus. Square root of this part is y. The sign that follows is a plus. Square root of this part is 7 squared, like that. So with the equation simplified to this level, we can extract center of the circle as 3, -7. 3, -7, like that. Then the radius of the circle as the square root of 36, which is 6 units. Now, after reflection, there is something I want you to notice, that when you reflect, the size of an object doesn't change. So the image and the object shall have equal radius. So the radius is not changing. Due to reflection, what is going to change is just the r. Look at this. I want to sketch it and make it very simple for you. Look at it this way. We have a circle here. 3, -7. 3 units. 3, -7 on the y. So we are reflecting along the y-axis, this one. That's where we are reflecting. To reflect means you take to the mirror line and you move an equal distance. So if the center was 3 units from the mirror line, it shall also be 3 units, but now on this side. So it shall be at -3 now. So we should have -3. So the new center shall be -3, then comma. We add 7 units on the lower side. Therefore, if from x-axis, we have 7 units on the lower side, it shall still be the same units on the lower side. So the center shall just be transported to this side, and the circle will be there. That's what reflection is. We just take it to the other side. We take it to the other side like that. Therefore, the new center shall be -3, -7. The new radius shall be 6. Expressing equation of a circle needs x minus the x coordinate of the center, making it a plus squared, y minus the y of the center, making it a plus, equals to 6 squared, which is about 6. So this is already equation. You know, we've not been told the format to leave it. So it's already an equation of a circle on its own. It is already a good equation for the circle. And I like the paper. Generally, the paper is it's an eye-opener. I hope you are getting what we are discussing in this forum. Remember to subscribe. Remember to share so that you may invite a friend. Now, in the figure below, A, B, C, and D are points on the circumference of a circle with the center O. You can see center O. Then we are further told that the line EF is a tangent to the circle at point C, just as you can see. Then the angle BAD, angle BAD, is 95. And the angle BDC is 72, just as indicated. Determine the sizes of the two angles given here. The angle BCD, this one, and also DCF, this one is also needed. Let's work out all those angles. Let's work them out. One thing you're supposed to know is that ABCD is a cyclic quadrilateral because all the points are on the circumference of the circle. And in a cyclic quadrilateral, we say opposite angles are supplementary. So we need to take 180 minus 95. 180 minus 95. This would give us 85 degrees. The reason there is opposite angles in a cyclic quadrilateral are supplementary. That is the mathematical principle that we have applied. Look at Roman 2. We need DCF. Already we've discovered that the value of the angle here is 85. Then we can apply more mathematics and say, if that is 85, and we are having 72 here, then we can get the angle at this point. So we need to take inside a triangle 180 minus 85 and 72. This shall give us 23. That shall give us exactly 23. Now, if that is 23, then the angle here is also 23. We usually say this, when a tangent is making an angle with a chord, for example, chord CD here, CD makes the angle here, the angle theta that we need has been made by CD, which is a chord, and a tangent. Then the same chord happens to make an equal angle in the alternate segment. That particular angle is usually equal. Therefore, this chord subtends an angle of 23 here, meaning that it left an angle of 23 at this point. We can also apply the same alternatively and say the chord BC is making an angle at this point and also producing an angle of 72 in the alternate segment, meaning that there will be a 72 also, meaning that there will be a 72 at that point. So we shall have an angle of 72 here. If that is 72, we can apply angles on a straight line and say 72 plus 85 plus the angle that we need should give us 180. And automatically the angle shall be 23. So we can apply the same principle severally, and the answer is confirmed to be 23. At number 14, a point A, xy is mapped onto A prime, x1, y1 by successive transformation K followed by T. Now determine the single matrix that would map A prime onto A. First, we're supposed to know that there is a matrix of transformation that can represent the successive transformation that maps A to A prime. And that is when we multiply the matrices in the order in which the transformations were performed. You know, it said that we started by K followed by T. So K followed by T is usually written like that. It means K was performed first, followed by T. So this is a 2, 1, 0, 1. Then we shall have 1, negative 2, 3, 0, like that. So in case we get this product now, it shall replace the two matrices and we will get a single transformation that would replace the successive transformations. Therefore, row times column, this shall give us 2 by 1 and negative 2 by 0. That gives us 2. The next, we multiply the same row by the next column. 1 by 1 and negative 2 by 2. So that's 1 minus 2, which is negative 1. Then we multiply the second row and the same columns. 3 by 2 and 0 by 0, giving us 6. Then 3 by 1 and 0 by 1, giving us 3. So this is now a single transformation which would map A direct to A prime. Because here we have two images involved. One, A was transformed to a certain image, then now to A prime by matrix T. But now a single matrix that would map A directly to A prime would be this one. Meaning that now we need a matrix that reverses this. Now, a matrix that reverses a transformation is the inverse of the matrix responsible of the transformation. I don't know whether you've heard that language. I'm saying this, a matrix that can reverse an image back to the object it was is usually the inverse of the matrix that is responsible of the transformation. Therefore, we need the inverse of this now. The inverse of this, whereby we need first to get the determinant, 2 by 3 elements in the leading diagonal, minus 6 times -1. You know, this is now 6 minus a -6, giving us 12. The determinant is 12. So the inverse now shall be 12 should divide every element, 12 shall divide every element, but now we shall have to change a few things. 3 takes the position there, and 2 the position here. We usually say that elements in the main diagonal change positions. 2 goes down as 3 goes up. Then for the elements in the other diagonals, the signs shall change. This becomes 1, and this becomes -6. So you can already get your mark at that point, but if further simplification is possible, then you can. We divide every element now by the determinant. 3 over 12 becomes a quarter, 1 over 12, and this is -1 over 2, and this is 1 over 6. Yeah, after multiplying by, after dividing by the determinant through. So that's how we work out such a question. Very good. A very good question. Very good one. Look at 15. A carpenter wishes to cut a 2-meter long piece of wood into 9 equal parts. He approximates the length of each piece to 0.22. Calculate the percentage error due to this approximation. We need, for us to get percentage error in this case, we need to get the error itself out of actual times 100. Error over actual times 100. So, actual value after dividing should be 2 over 9 pieces. But now, there is an estimate value here, rather an approximate 0.22 meters. Then we can get the percentage error, whereby we need the error. No, I am to check first. Yeah, we need the error 2 over 9 minus the estimate. You know, the meaning of error is the difference between actual value and estimated value. So that is the error out of actual value multiplied by 100. So 2 over 9 minus 0.22. Then we divide by 2 over 9. We get 0.01 times 100, giving us exactly 1%. So there is a 1% error involved. You're supposed to use your calculator very accurately at that point. 2 over 9 minus 0.22. You put an answer. Then the answer divided by 2 over 9. Then now you multiply by 100. And you get a percentage error. Looking at number 16 now, which is the last question in this section. Now, the population of a colony of bacteria was recorded at intervals of 5 seconds, as shown in the table below. That's the table. Time in seconds, then the number of bacteria in this particular colony. On the grid provided, draw the graph of population of bacteria against time. The axes have already been labeled very well. So we need now to just plot 0 and 5. So this is the first coordinate, 0, 5. Then 5, 7 bacteria, 5, 7 bacteria just above 5, 10, 11, 15, 16, then 20, 24, 24 is just below 25, just below 25, then 25, 36, 25 and 36 at that point like that. So we have the points properly plotted. Let me do the curve. Curve should be very smooth. Very smooth. Without any joints, no. Now we must finish up with this one if the paper misbehaves. So allow me kindly, allow me to bring the paper to you. Oh yes, here is the paper. So sorry for that. But we have to continue until we finish the plotting of this particular curve. 0 by 5. 5 by 7. 10 by 11. 15 by 16. 20 by 24. And 25 by 36. 36 is here. Yeah, slightly above 35 that way. But now we join smoothly. That way. So we have the graph for population against time in that particular column. Part B, determine the average rate of change between t equals to 5 and t equals to 20. T equals to 5 and t equals to 20. Let's check. T equals to 5 and t equals to 20. You just need to get the gradient now between those 2 points. You join them using a straight line, then you obtain a gradient. 5 and 20. So you just need the gradient now for this particular line. Yes, 5 and 20. So we read any 2 values lying on that line, and that can be 5 and 7. Then we have 20, 20 and 24. So the gradient shall be the rate of change. 24 minus 7 out of 20 minus 5. 24 minus 7 equals to 17. And 20 minus 5 equals to 15. So this can be written as 1 and 2 over 15. This is the rate of change of bacteria per second. So that is the paper, the section 1. Later we'll be meeting for the section 2, and I request you to kindly subscribe to our channel, invite your friends to this so that they may also benefit from our program. 07 04 15 03 66 is our consultation line. You can reach out. Thank you. See you next time.